Hello there. This video is going to be a little difficult to ease into. So let me give you some backstory first here so you can understand where we are currently at. This is my IBM 5160, and I have been trying to get PCB editing software running on this thing for a long time now. This is PadsCAD, and this is so far the best possible attempt that I've had at getting something to run on this machine that I could design and get fabricated a circuit board. Now, this is just a weird objective that I've had for a while, and I've been trying to figure it out. The Mouse Systems Mouse video I did recently was actually a step towards making this happen, but I've run into an issue. Now, I mentioned this is the best software I've gotten to work on this so far, and that's because, kind of surprisingly, 80s CAD software is not easy to get. Even this, I think it's from like 1991 or 1993 instead. Yeah, copyright on this is 1990. It just so happens to work on this machine though, even though technically it states it needs a 286 or better, but it doesn't, thankfully. But the main problem is the video display requirements of this thing. At minimum, it needs an EGA monitor. And unlike some software from this era, it genuinely means it because it runs it in one of the fancy pants EGA high resolution modes. Now, I don't have a functional EGA monitor, so what I've been trying to do is get 8-bit ISA VGA cards working on this thing. And I even tried this, which is the Trident 8900 VGA card, and none of these have worked. These ones are just not compatible, the 8-bit ISA slots, if I remember correctly. And that one, well, that one actually was just dead. It had corrosion, and I attempted to fix it quickly, couldn't get it working. And that is where I was at when I recorded the mail video, where I mentioned that this computer was kicking my butt. Now, what I hadn't mentioned in that mail video is why I'd backburnered that project, because after that card left me so distraught, I just had this wild idea to just buy an EGA monitor. Why not? That would just solve the problems, right? Well, EGA monitors are not inexpensive, but right when I had this harebrained idea, there was one freshly listed on eBay, and I just bought it without even thinking about it because it was broken, which made it cheap enough that I could actually justify purchasing it. And what was even weirder is that after I bought it, I realized it was actually within driving distance of me. So I went and picked it up myself. And here it is. It's not permanently damaged, and I think I have a solution in place for it. But we're gonna have to do some work on this thing. And this is why you're joining me partway through this project, because I've had to start working on this thing, and these are apparently very stupid because some of these components are riveted together inside, and I didn't realize that until I was already into working on this and I didn't get good footage of it. So rather than fake that as if I was pulling this apart for the first time, we're just gonna go ahead and start from right here, because I actually have already looked at the circuit board and ordered all the capacitors we will need to totally refurbish the internal power supply. With all that out of the way, let me give you a little more information on what this is precisely. This is an IBM 5154. This is the first EGA monitor that IBM designed and is instantly identifiable compared to the CGA monitor by the white knobs. That's the biggest difference you're going to see in how these are visually designed. The EGA monitor is actually a little bit bigger and heavier as well, but that's a little more difficult to tell unless you just have them both right there. Now, what makes the EGA monitor special is that it is still a 9-pin digital video interface, but in addition to the 3 RGB control lines, it also has 3 RGB intensity lines, which makes it possible to have many more colors be displayed at once, because you don't have a single color intensity pin like you do on a CGA display. Now, CGA displays can fake the default EGA palette using that one intensity pin, but this gives us access to way more colors than you can ever hope to get on CGA. Additionally, EGA monitors can do some different sync timings to get higher resolution support going as well. And I'm hoping we can do that in the 5154. I'm not actually 100% sure. Pretty sure, but I don't know, because that's ultimately what made PADS-CAD not work on the CGA display. The colors were fine, it was the resolution. Now, 5154s are somewhat infamous for the power supplies going bad, and yeah, this one went very bad and sprayed cap crud all over inside of the housing. Now, there is a lot going on this board, but not all of it is bad caps, but I can show you the main bad cap in here. Going back to the original description I purchased this from, it was described as does not work, needs repair, made some crackles and pops when powered on for testing. With a description like that, I have not attempted to power this thing because I knew that that power supply was going to be an issue. And after figuring out how to disassemble this thing with a drill, I saw this. Now, don't worry about the brown stuff all over. That's not actually a problem. But what you can see down here is this black rubber thing, which is the plug for this capacitor, having been ejected after it heated up. That is a blown cap right there. It will definitely result in some crackles and pops if you try to power this thing on. So that is a definitely known bad part in this thing. And now you're caught up with me. That is as far as I've gotten in this thing. I haven't even removed the REFA capacitor right there and right there that are clearly going to need to be removed because we don't want those exploding either. My primary focus was this, getting a list of replacement parts that I could use to rebuild that board. So now we're going to be able to make this thing brand new as far as the capacitor side is concerned. And yeah, we are only going to recap the power supply, not the whole thing. Power supply gets a lot hotter, so the capacitors are chemically aged faster. Hopefully that will be all that's needed to make it work.
Oh, you poor naive fool. You have no idea what's coming.
Everything else shouldn't be as bad, so hopefully between those, we'll have this thing working by the end of the day. Now, before we start ripping parts off, let me take you through the diagnostic steps here that led me to purchasing the caps that I did. Even though I did buy all of them, that probably wasn't necessary, but I'm in this far and this is a known problematic area, so I'm just clean slating it with new parts. But when you look at something like this, you're going to see residue and fluid leaks and just stuff generally all over the place. And I believe we have 4 different kinds of fluid on this board, which doesn't seem great at first, but at least 3 of those were there when this thing left the factory. Now, the first and easiest one to rule out as a problem is the silastic or silicone that's on this transformer. That would have been done to protect the windings on this thing so that it doesn't get shorted or damaged or corrosion, any of that stuff. That is totally normal. Next, we have what looks like leaking capacitor goo all around here, but that actually would have been epoxy to hold the caps down during shipping. These huge caps can wobble around, and if you have them shift too much, you'll end up with cracked solder joints, which I actually just saw some on some tandem floppy drives, which made those not work, shockingly. And then we have the goo that seems to be all over the board, especially on the edges here. That is possibly flux from the soldering assembly stage. And if we look at the bottom, we can see some brown around some of the larger solder pads and possibly right here too. Now, there are several different kinds of flux. This is a flux pen, but this kind of flux goos up just like this if you leave it on there. And it can look gross, and some of them can be problematic, but in general, that's not a sign of a problem, and most likely isn't a problem if it left the factory that way. But there will definitely be some things that are a problem related to the leaking capacitors on here, and it's going to take some investigation to figure that out. And one thing I'm seeing here, I don't like the green on that. That could be a sign of the electrolyte from this mixing with the epoxy. We'll have to get a closer look at that when we remove all the capacitors here. But for now, I don't see anything too bad. And since this is a single-sided board, we don't have to worry as much about plated vias because there aren't any. So as long as we don't lift anything on this side, we're going to be fine. So we're going to go ahead and start removing capacitors on here, primarily in this area, but I am going to remove all of them, including these, which may not need to be replaced. You might see the bulging on top on these kind of caps. I think that's an issue, but that's actually the plastic disc that's put over the top of it being compressed by the jacket. So that's not as much of an issue as you would think. But we're going to go ahead and do it because, again, the Synchron's hot. They've all been exposed to heat for an extended period of time. So I'm just going to go ahead and replace them all. All right. Now, I'm going to go ahead and remove these all in bulk using my desoldering iron in a moment. But first, let me just go through and check that I have every single one of these. So C31, check, check. And the all-important C29. So, yep, all the electrolytics are confirmed and ready to be extracted. And there we are, all of the capacitors off of the board. And yeah, it looks pretty good overall. I am concerned about the green spot. That certainly doesn't look good, but there's nothing to corrode because it's just the glue that was holding on the big caps. So once we scrape it off, I mean, there's nothing left. It could be the diode, but it seems fine. So yeah, I'm going to go ahead and just ignore that. I am curious about the main filter caps, though. Do I actually need to replace these? Because everything I've heard says that these usually are fine. So I'm curious, put them on my capacitor meter here and see how they register. So 195 UF, that's about 10% off of the cap. That's probably a 20% tolerance. That seems totally normal to me. ESR 0.07 ohms. Is that 1 kilohertz? It's a little difficult to know what frequency you're supposed to use without the data sheet to measure the capacitors. However, every frequency rating here looks pretty darn good. So yeah, these probably don't need to be replaced. They look totally fine based on what I'm seeing here. But like I said, everything here was heat soaked. So we're just going to go ahead and do it all anyway. But it is good to have a confirmation that you can probably skip these in most things because they're kind of pricey for caps. But since it's going in at 51 and 54, I'll go ahead and spend like $10 extra on caps for something that's going to be worth several hundred, hopefully, by the time I'm done. Not that what it's valued at means anything to me. I see that as money saved by buying a broken one and fixing it rather than spending the large sums of money that they normally sell for when they work. All right, now I'm going to spend a little bit of time cleaning this. I'm not going to go crazy because if I wanted to do that, I would just remove all of the transformers and inductors and put it in my ultrasonic cleaner. But I don't really want to do that. So we're just going to give it a basic wipe down here just to make sure everything's looking good. Because keep in mind, it left the factory looking terrible. It's just how it's expected to be. All right, with some cleaning, I can see one potential issue here. That trace right there is looking kind of corroded underneath, and it doesn't help that they drilled a hole right there for some reason. I don't like that, though, so I may bridge a wire between this L4 pad and the C29 pad just to be sure that that's not a problem going forward. So yeah, that's the kind of thing you want to keep an eye out for. Nothing else looks anywhere near that bad because I don't think any of the other capacitors were that bad. Again, factory flux job there. All right, I'm giving up on cleaning this thing. There's so much flux that every time I start trying to clean up these white spots that have formed on here, when I go to dry it, they just come right back because I'm not able to emulsify all of it to get it removed. The only way to fully clean this board would be to dunk it into my ultrasonic cleaner for probably several passes because it's just that bad. It's so bad. IBM just like dipped this sucker in flux to work on it. So yeah, I'm not going to clean this right now. I know in reality that probably means never. But yeah, this is way more than I'm wanting to get into right now when I don't even know this thing works. All right. So we're going to, at this point, put all of the electrolytic capacitors back on here. We'll fix the one trace that I noticed or put in a preventative wire just to make sure that it doesn't break more. But yeah, other than that, it does look pretty good now. So I'm ready to start the reassembly. So I'm just gonna pick up a cap at random here. I'm gonna go ahead and start putting them in. I am making a last minute adjustment to what I am putting in here. So the IBM 5154 page on CapsWiki was initially not filled out by me, which is awesome. It means that other people are using CapsWiki. It's fantastic. In case you don't know what CapsWiki is, I'll link my video on it below because it's a website I run for listing capacitors for repairing things like this. It's a phenomenal resource. But someone else had already done 5154. And it turns out there are several revisions of the power supply capacitors that get put in this thing. And they had put a 47 UF 35 volt cap in C11 here. But as a sanity check, as I was replacing every single one of these, I was looking at the caps that I pulled out of mine, and mine's a 100 UF. Now, I don't know that that's going to make a huge difference, but I had ordered the 47, and it feels weird to put the wrong value in there. Now, I dug through my parts bin, and I do have some 100 UF 35 volt capacitors. And they're reasonably quality. What are these? They're Rubicons. They're going to be nice enough. So I'm going to actually go with one of these, which means that the parts listed on CapsWiki versus the ones that I actually ordered and put in here are going to be slightly different. But I'll go ahead and mark that on the website after I'm done here. That way the difference can be noted. But yeah, I was not expecting that. Glad I double checked everything. Probably would have worked elsewise since that both have been found in there. I'm not sure what it is, but again, I'm going to go ahead and put a matching 100 UF in there instead of the 47 UF that was listed on CapsWiki. I'm also slightly annoyed. In the past, I had been ordering a minimum of like 10 capacitors or double what I needed for each project. More recently, I've been only ordering enough, and that would have made this impossible if I'd been doing that. So you know what? I need to go back to over ordering on parts because it is nice to have some on hand, especially once I found nicer ones that I really like. So yeah, this is only possible because I previously did that. All right, I had been saving the best for last. So this is C29, the one that actually exploded on mine. One thing I did not show earlier was how the case has rippled here, or the jacket, I should say, because the case itself got really hot. This thing very, very clearly blew. The plug has been completely ejected. Yeah, that's one bad cap there. For the corroded trace, what I can go ahead and do is just bend this leg straight over there, and then I'll just be able to solder it in both places. And yeah, then I don't have to run a wire, and we'll have a very solid connection. That should be perfect. And lastly, the two main filter caps. And every time I order new ones of these, I'm always weirded out because they make them way shorter now. It just feels wrong. And there we are. All the capacitors are replaced. So moment of truth, I get to put it in and find out if that was the only problem. Okay, that's the power supply attached. I think I can test this now. So, I am going to put this down. I'm going to put this pink foam here because it has to rest on the board for now. And I think I can try plugging it in and turning it on and see what happens. I don't know what the EGA display does without a video signal, but I do know that the CGA display will show white. Additionally, there's a green power LED on the front, so theoretically you should turn that on too. So I'm going to get set up and we're going to try that out. Okay, it is set to the off position, rotated counterclockwise. I am going to plug in power. Checking CRT neck is on. Okay, here we go. I felt it charge. Everything looks right. That's video. Okay. I think we need to try driving it now. Ooh, okay. All right, so this is my 5160 here. I am going to put an ultimate EGA plus, just whatever generic EGA card. I'm going to put this in the 5160 here. And then plug in video here. That's RAM counting. It's warming up. It is super dim. Yeah, colors are not right. So it's tinted red, which is what happened to my CGA monitor before it died. But it's totally working. I'm a little nervous about all the colors. I suspect I am not done with the capacitors in this, but that's actually working. All right, CD, pads, demo, PCBs. Oh, kind of working. The size doesn't seem quite right. So there's V size 1 and V size 2. And it's clearly V size 2. And that pot's very dirty. The collapse of the beam like that can be slightly bad. It can put too much energy into the phosphor in the center, so I don't want to leave that running. I'm going to really quick, it's not damaging it yet, to be clear. I'm going to put some deoxit on that pot. Well, that's weird. Why did that happen? H size 2 is clearly working, but then it lost sync. I'm going to restart the computer. Somehow messing with the vertical size knobs just collapsed the video. I don't get it. Maybe I should try getting some deoxit on the contrast knob since it's just straight up not doing anything. Okay, contrast still doesn't do anything. Man. So I just removed C304, which sits right there on the board. And it's a 2200 UF cap measuring as 1400 UF and pretty high ESR there. So may have found a problem. Not sure if that's the problem. I'm going to go look at the schematic in a second to see if that's related to the vertical deflection. But yeah, that's not good. So C304 here was 2200 UF 16 volt. I have a 2200 UF 50 volt, which I can put in here as a quick test. So I think I'm going to try that and see if that changes anything. All right. That was a nice thought. Broken cold solder joint on the connector board for those adjusters. That is all of the connectors for the two vertically mounted boards. Reflowed. Man. Thing is, I did something stupid that made it change. All I did was adjust the potentiometer. So it doesn't make sense for it to be something complicated that caused the issue. Like a cap failing. That's my logic here. Due to how the partial vertical collapse happened, I'm somewhat convinced that it's not going to be a failed capacitor or something. It probably needs recapped on the main board. Don't get me wrong. But I really feel like that was a spontaneous failure, not the gradual kind that you usually see from capacitors. And I may have figured out what it is that caused the spontaneous failure. It would be a very spontaneous issue, like a failed solder joint. Now this solder joint has a visible crease along the left edge here. You can see that right there can cause a disconnect, which may seem crazy since it's so much metal touching metal, but I've seen it happen. This is a common problem. It's called a cold solder joint, and this is far from the only one
on here. This one also has it there. I don't necessarily see it there, but I did see one up here by this capacitor thing, somewhere around here. Yeah, so that resistor, there wasn't enough solder, and you can see that the solder is kind of cracked around the hole because it's so thin. So yeah, I'm sure if I keep looking here, I'm going to find more cracked solder joints, especially where the pins go all the way through. It seems like time has just been having fun with this. Actually, I think I see it on one where it's bent over right there on the right. Yay. So what I might need to do here is remove the main board and then reflow every single pad on here just to make sure that they're all good. Oh my gosh, what's going on with that one? Yeah, because I'm thinking maybe it could be the result of a cold solder joint from me moving it around. That one looks a little suspicious.
So what I'm going to want to do based on that is pull out the logic board and individually reflow every single one of those points. Like, I should probably just do the whole thing because some of those don't even look like they're on heavy components. Like, I'm pretty sure one or two of those were resistors. So the solder is just let go. It's just, man, annoying. So yeah, I'm going to do that tomorrow, and I'll just join in with you after that, because I don't think that just touching the soldering iron to every little thing is going to be all that exciting to watch.
In the end, bad solder joints aren't what was causing my issues with this thing, but I want to look at this footage from a little bit later that I shot while touching up some of them, because just what the heck, IBM? This is some of the worst soldering and the most broken joints I've ever seen on a PCB. Even though it seems these weren't causing an issue now, this thing definitely would have had problems with this in the future, and especially after being moved around a few more times. There are broken solder joints all over that are bad or starting to fail, and this is just one small section of the main PCB. I found them like this all over the whole thing. So I spent a good amount of time touching this thing up with my soldering iron after I did some more work. It's ridiculous how bad it is. So if you have one of these and some of the other things I end up trying in this don't solve the issues for you, definitely look at the solder joints, because this is just so bad. Again, what gives, man?
All right, it's day 2 now, or day 3 if you count the first day where I actually picked all the cap values out. And I have basically completely torn it apart to get down to the main board inside. Everything has to come off. But it was worth it because I found something beyond the cracked solder joints. Yay. Now, this angle is about all I could see from the back without having removed it. But as I tip this forward, bam, fuzzy jumper right there. And looking at the side of this cap, the jacket appears to have been damaged. So I'm guessing that cap is completely dead there. Again, don't know if that is a solution to the problem or not, but it isn't going to be helping anything. Now, the reason I was looking in here, because I started doing some research, and on the -0 degrees site for this monitor, C311 is marked as something for the vertical fold over. That's that problem I was having where the image was like wrapping around the top. So I was trying to get a look at C311 here, and that's, yeah, part of when I noticed the green fuzzy nonsense going on over there. So we're going to yoink that sucker. It is a 47 UF 200 volt cap. Don't know if I have one of those on hand. But yeah, that's very annoying. Now, real quick, while we're over here, this is the vertical sweep controller IC, I believe. And this is why this whole area is important. This is the connector where those knobs in the back went, which, by the way, that has been fully removed, and I attempted resoldering the pins on those. That didn't help anything. I was hoping maybe when I moved the knob, I broke the solder joint on the back, but no, that wasn't it. So it kind of makes sense for caps in this area like that one there to cause a problem. And oh yeah, this chip is apparently known to fail too. Thankfully, it's not unobtainable. I should probably just order a spare to keep on hand, actually, because they're really not too bad for a part that's definitely not being made anymore. The bottom of the cap looks fine, and it reads like bang on. Frequencies may be a little weird, and the ESR might be a bit high, but that's not leaking and failed. What's causing that corrosion? I don't see what could have caused that. The cap area underneath looks fine. This is glue that's holding it down is actually on the opposite side of the vent hole on the cap, so I don't think that one leaked. Under here, there's a TO2 transistor or something. This, I don't think can leak. Legs look fine on it, too. I have no idea what may have got on that. I checked it from the underside. Continuity is still good, so it's fine. That's super weird. Well, C311 is the same story. I wouldn't call it great, but it's within spec. It could be causing the issue, but I don't have a replacement. I looked through everything I have. 30 or 40 volt 100 UF is just kind of high voltage. So, yeah, I don't have one of those on hand. So back in it goes, and I will try touching up all of the solder joints. I just finished doing all of the capacitor lists for the boards here. I think I'm going to go ahead and just order those rather than try and reflow every single part on the main board, because I'm going to be reflowing them if I replace them. So why not? And had a realization while I was staring at all this stuff that I think this is 2 screws away from the entire motherboard assembly. And not just motherboard, actually the entire PCB framework assembly with both modules being able to just be slid out. So if I remove these two, yeah, I could have slid out the logic board intact with the power supply and the video display board all on there, and I would have had to unplug this, and the neck board. Oh, and these and that and okay, so a bit of stuff, but I had to unplug it all anyway. Then I wouldn't have had to deal with the flyback resistor, whatever that multiplier thing. Actually, that is the flyback, isn't it? Huh? I don't know, it's like a 2-stage flyback. It's weird. Anyway, I'm gonna remount the main board to this and then work on stuff. Blah. This monitor is being a real pain in the butt.
There is no way I am editing down the 1.5 hours worth of footage of me just replacing these capacitors into some kind of fun timed thing. So, enjoy this just sped up section with voiceover here that I'm currently talking over to stretch out this part so that you can at least kind of see what happened. Yeah, this is the fun balance you have to strike when editing videos. Do I just throw this footage away? Do we cut to the next part? I have no idea what makes the most sense to do, so yeah, there's me doing it in the background while I say words over it. I'm breaking the fourth wall a bit here, but this project really just drained me because of how much effort it took to do all of this.
All right, it's been a lot of work, but every single capacitor in this, with the exception of C120 and whatever the other 22 microfarad caps on this board are, and also what is it, C208, turned out to be 0.47 microfarads at 35 volts, I presume, at 50 volts. Those didn't get replaced because I'd missed the 0.47 one, but the other set I had read wrong and thought they were 2.2. But all of the other caps are replaced. I don't think that those values that I did not replace are going to be relevant to the vertical sync issues, so I think we're good. I just went over all of the caps again to check the polarities of how they're mounted. I had to fix one, but I think I'm done and can start the reassembly so we can see if we fix the vertical sync issue. Oh boy. All right, let's begin. I have this better labeled this time and Haven't dropped the box, so this should go together a lot smoother. I think that might be it. I'm going to turn off the camera now and once over everything, and then we're ready to fire it up and see what happens. It's all plugged in, so here we go. Power. Didn't explode. I like that, but it's not turned on either, which let's go ahead and do. No explosions. And VSync. Ah! Seriously? Well, good news is it's looking a little less purple, so it helped somewhat. Well, we're not down and out. We have one last thing. The vertical deflection chip. Still would not be surprised to find it's an issue with this board, but I reflowed these, so I can't see how it is, unless maybe a cable died. Okay, so right there is the vertical deflection chip, and it's retained onto this copper heatsink. I don't really think there's a reason for me to disassemble the chassis any more than this, so I'm just going to remove it through the side here because, again, it's not really going to make a difference how I take it out. So I'm just going to do it this way. All right, well, I completely failed to hit record while I was replacing it, but long story short, this is the old chip. They do match, and it's just held in with a spring clip, which goes to some thermal paste stuff on the other side. So yeah, but from here, if this doesn't solve the problem, then I'm on my own, and we're going to have to refer to the Sam's Photo Fact and start probing traces, figure out what's going wrong with this thing. Because at this point, man, I don't know what it is. Hopefully this fixes it. Okay. That's the last repair that I can think of. All right. Wall power. And turn it on. Oh my gosh. That's it. Oh, that's full scan. Oh man. Oh. It was the vertical sync chip. Oh my gosh. So yeah, that thing took it out. Are you kidding me? Oh my gosh. Well, there we go. I want to try this with the 5160 now, but I should note that a recap was mandatory no matter what, at least for the main board. So if you remember, the initial thing that caused me to touch those vertical size knobs was the fold over, as I've learned that it's called, at the top of the image in the high-res VGA mode. That is caused by capacitor C311, I believe, going bad. So no matter what, I did need to recap parts of the main board. So it wasn't a waste that I did all of that. It was just more than I probably needed to do. But it's done now, and I mean, it's not a bad thing that I went ahead and did all that. Now for the realer moment of truth. Running it with the computer. Now my sizes are probably all messed up, and I messed with basically every setting we could have here. So we're going to let it get into DOS and then try and print some stuff on the screen to figure out how I have this thing set up right now. That's technically correct. I think I messed with the sub brightness. Yeah, I need to bump some stuff up in the back, which I can kind of get to. All right. I'm catching you up. I was doing a live stream and I kind of just meandered into this, but the G2 value here was the issue. So I can get that pretty much right there. And that is in fact the 5154 fully working. Oh my gosh. Oh yeah, that's awesome. Oh yeah, let me adjust the vertical size here for this. So yes, beautiful. Oh man, that is correct there. On that, actually, here we go. Let's check something. Alt F X to escape here. We're gonna CD pads demo. And then PCBS. That's not, the blue convergence is not right on this. Uh-oh. It's really dim, but yeah, blue convergence is not, not quite right. Or blue is bleeding, I'm not sure. Drat. Well, that's gonna need some resolving. But PCBs, okay. This is a critical test, because this is going to run in high-res EGA mode. Oh, it's perfect. It's perfect! Yes! I don't know what to do about the blue convergence. I'm nervous about that. It is possible I need to adjust the phase, but I'm not sure, because I messed with everything. Oh, man. That's excellent.
Now, despite being on cloud 9 for just having the monitor work, I really wanted to get that convergence issue solved, which required me to learn how to deal with convergence rings for the first time. Thank you so much, Matrox Millennium, for guiding me through this process. Getting the separate R, G, and B dots to move around is a very weird thing. This whole process is very non-intuitive, but with enough trial and error, I was able to get it to a point where it was slightly better. It turns out the blue channel seems to be bleeding. My best guess is that the 22 microfarad capacitors that I did not replace on the video board might be the problem. Maybe, perhaps the one on the blue channel is bad. So I may have to open this thing up one more time to replace those caps, but that's as much as I could get out of it. I tried adjusting the individual color channels as well on that board, and it made no difference. There's just something bleeding in the blue channel, so that is going to have to be a problem I solve at a later date. But for now, I'm just reveling in the fact that it works, and I solved the major issues that were preventing it from working, and at this point, I'm just so happy to have this thing even be functional.
That is such a good sight to see. Oh man, it works. Ah. Fire up, edit here, see it, boom. Yes, so good. Turn up the brightness a little bit too here. Oh man, that's nice. That's nice. And then close out of this, switch over to the PCB editing software, and we get a real EGA demo of an application running in high-res mode. Oh, it's so nice. So that is the 5154 fully repaired. This is not synced. I normally have this synced to 60 hertz, but high-res mode runs at a different refresh rate. I don't actually know what refresh rate it is. I'll have to look into that. For when this comes back in the PCB design on an 8088 video that I should be doing, sometime in the future. I'm not going to say soon because there are problems with this software that I haven't solved yet to actually make a PCB, but we'll cross that line when we get to it. But that is the monitor working after so much effort. So I hope that was educational, seeing everything that went into that. In the end, I did not need the Sam's Photo Fact, but I'm much happier having bought that and scanned it to get that preserved in a better quality than was available before. But yep, that was it. If you enjoyed this video on restoring this incredible monitor, you may want to subscribe to be notified when the next one comes out. If you want to help support the channel, you can find me on Patreon. But for now, that's it. And I'll see you next time.